All right, welcome to 3.3 Properties of Logarithms. It's an exciting section because we went over. I'm a big fan of logarithms, so it's gonna be cool. Uh, I would recommend you pause, jot down these lovely rules. We're gonna be applying them for the rest of these guided notes. Okay. Product. So anytime you're multiplying two numbers, you can separate them into two logarithms and make an addition. Division, you can separate, making two logarithms, make subtraction, and then the power. Anytime you have an exponent with the term in the logarithm, you can move it up front, make a multiplication. And likewise, the reverse also comes into play. If you're adding two logarithms with the same base, you can combine them by multiplying whatever the x value and the y value is. Um, Same thing here if you're subtracting logarithms with the same bases. Keyword, they must be the same base. Um, you can make it one logarithm divide. Okay, so let's do some work with this, shall we? So here's an example of problem. So express the logarithm in terms of log of 5 and log of 3. So this is good practice of using our three properties. I'm going to try to find, can we fit all this in one? Yes, we can. Okay, cool. So in terms of log of 5, so are we able to um, factor out of 5? Yes. Anytime, as you might remember back in your elementary school days, anytime you see an ending with 5 and a 0, you can factor out a 5. So if I take out a 5, some of you might be able to figure this out right away without me doing this portion of the work. If so, great. Love it. But I'm going to show you steps in case you don't recognize it right away. So 5 times what gets you a 75? That's 15. Are there any other factors of 3 or 5? Yes, there's in fact a factor of 3 and 5, because 5 times 3 is 15. And I'm going to go down one because I'm running out of space, because I'm writing way too big. And you're adding them so you can multiply. So 5 times 5 now. So I'm going to make it 1 because that's going to make it look a lot nicer. So I can make this 2 log 5. Now you might say, Mr. Barton, can I make that log 5 squared? Um, Sure you can, but then we can simplify and move the 2 up front because of our power property. Once again, your teacher wrote too big. I apologize. So let's go to the side here. We're going to evaluate these logarithms. We're going to be using the rules. So I see third root, and right away, um, I'm going to make it a 1/3 power. Okay, because anytime you see square root, it's 1/2 power. So I'm going to do 1/3 power, and that's just to the 36. Now I'm going to say this a couple times here. There's multiple ways you can do this and still get the right answer. But what I need from you is to show some kind of steps of using the properties. Um, One of those things is I recognize in this case it's a 36. Okay, so and I know that 6 squared is 36. So why is that important? If it's 6 squared is 36, and this is a 6 as well, from your last section, you know that if these values are the same, your log is then equal to 1. And that will make life easier as well. You might also recognize another way to go about this. You see 1/3 power, you can move the 1/3 up front and be able to solve for log base 6 of 36. And do the same method I was explaining about earlier. So what I'm going to do next is log base 6. I'm going to do what I said the first time of 6 squared to the power of 1/3. Now, power to a power you multiply. So I'm going to get log base 6 of 6 to the 2/3 because 2 times 1/3 is 2/3. Move the 2/3 up front. And remember, log base 6 is 6. That's the number same as times 1. So your answer is 2/3. I'm a big fan of working with natural logarithms because they're kind of easier to work with. So I'm going to use my exponent rules because, yes, this is a 9. This 9 right here goes this problem, so that's part of us. So I'm going to bring the 9 up front. 9 ln base e plus, I'm going to bring the 3 up front, and since you're bringing it up front, it's going to, remember, you're multiplying it, so 3 times 4 is 12. Now, ln of e, if you remember, is equal to 1. You should remember this from last section. So, and then 9 times 1 is just 9. Once again, 12 times 1 is 12. 9 plus 12 is 21. 21, can you do something for me? I'm sorry. I had to go there. So, in all, use your rules, be able to solve. Yes, I'm a big, as I said, big fan of ln base e. Helps us out a lot. So let's expand these logarithms fully. Okay, so we have two different problems with two different kind of setups that we're going to need in order to expand. So we have log base 13 of 6 times a to the power of 3 times b times c to the power of 4. So I see a lot of multiplication here. So when we think multiplication and then we're going to be expanding it, we're going to switch it to addition. So I'm going to straight up add 6, add a to the third, add log base 13 b plus log base 13 c to the fourth. You're not done yet, okay? You did not fully expand yet, because in order to fully expand, we are going to be moving the exponents up front and making multiplication. So I'm moving the 3 up front. And that's fully expanded. Okay, cool. Another thing you might want to look for in problems like these is if anything like over here, when you see a number, can it be something we can find that becomes a whole number? Clearly no, because base 13 and 6 aren't going to match up nicely, unfortunately. So that's it. So that's it for that one. So let's use a different color to kind of tell the two apart. For the next one, we have ln of 3y plus 2 all over 4 times the third root of y. So a couple things with this one, I'm kind of trying to trick you a little bit. First we see division, right? So anytime we see division, let's separate them. Put parentheses around the 2y plus 2, or excuse me, 3y plus 2, minus ln of 4 third root of y. Now, one thing, we cannot touch this 3y plus 2, okay? It's tempting. If it was 3y times 2, then yeah, sure, let's separate them. But it's 3y plus 2. You cannot separate the 3y and the 2 in this case. But we see after a subtraction sign, we do have 4 times that, so we can make that addition. I'm going to put parentheses around that because the negative sign is going to both terms. Anything we expand, it needs to go to both. Very common mistake of this problem. So I'm going to make sure to distribute that negative both. And the last thing is we have a third root of y. That's like saying to the 1/3 power, so I can throw that up front. So your final answer will be 1/3 up front times ln y. There's your answer. Now let's condense. So I see this negative 5 multiplying by the log, so I'm going to move that to the exponent. So log base 2 of x plus 1 to negative 5th plus, same thing here, I see a 3, so I'm going to make that to a power. 6 to the third power is 216, and then x to the third. I'm adding, so that whenever I'm adding, I'm trying to make it into one logarithm. Your goal is to have one single logarithm. Okay, that's what we're condensing to. So I'm going to be multiplying, so log base 2 of x plus 1 to the negative 5th times 216 x to the third, and we can make this look a little prettier, we have a negative exponent. Your answer should never have a negative exponent in your final answer, ever, ever, ever. So I'm going to throw that in the denominator and make it positive. 216x to the third. That's it. Some of you might be trying to cancel out this x to the third and this x. No, you cannot do that because it's x. If you're adding a value to the x, that's not x. It's 1, and then plus it's to the fifth power. You can't do that. Next, this one. So I see subtraction, so you're dividing. So divide one at a time. Also, I see that 4, so it needs to go to the exponent, okay? So we got ln of 3x plus 5 over x to the fourth minus ln of x minus 1. You're dividing again, so we're going to throw that x minus 1 to the denominator. So you're going to get ln of 3x plus 5 over x to the fourth, x minus 1. There you go. There's your answer. Sorry, I thought I paused the video. But anyways, so change of base formula, very simple. Log base b of x is equal to log of x divided by log of b. Your book writes a little differently, but this is how I like to write it because when you put in your calculator, it's much easier just to use your common logarithm of base 10 and punch in your calculator right away, and you get an answer. That's the point of using change bases. It's really easy to put in your calculator compared to other things. Yes, you can go other ways, but of typing your calculator, but this is really simple. You can use your base 10 to go from there. So let's do a quick example, and then we'll move on. So let's say we have log base 15 of 33, and then so the big number goes up top, so log 33 divided by log of 15. Go ahead and punch out your calculator, make sure that you're closing parentheses and all that good stuff. And that's going to should get your output of 1.291. 3 decimal places is plenty. Thank you for watching. I appreciate you, and we'll see you in class. Bye-bye.